Okay.
Show's yours.
My name is Jack Burnham, and I haven't been accepted as a member yet.
We'll see how it goes.
We'll see how. Well, I've got a lot of riding on this
We'll
presentation.
let you know after the presentation, yeah.
So what I want to do is talk about how the T41 came about. And I've got a unit here, if you want to take a peek at it afterwards. What happened was in 2019, we, Al Peter and I went to a field day down in Madison, Indiana. And on the way back, he took a 100-watt rig, I took a G90, which is a 20-watt rig. And his rig was not an SDR, so it had no spectrum or waterfall. But the G90 had the spectrum and the waterfall. So on the way home, we were talking about what we would like to see in a transceiver, an SDT, software-defined transceiver. And this was the list that we came up with. We wanted a 5-band, high-frequency, software-defined transceiver. We wanted it to cover 80 through 10. That was the original design goal. We wanted it to be able to do single sideband and CW. Fuzzy QRP. We figured 20 watts, but you could dial it down for those contests that require 5 watts. We wanted it self-contained, and this was a big thing. We didn't want to drag along a laptop or PC or tablet. So that was very important. We wanted it trunk portable. And what we meant by that was, that's not something that you would want to strap on your back and hike up a mountaintop to set up. But you could throw it in the trunk of your car, go to your fishing cabin or whatever, and throw it up. That would work. Reasonable cost. And what we wanted it to do was to be competitive with the G90, which at the time was selling for around $450. And it's not cheap. But the one that we built, well, I'll show you that later. Reasonable cost, and we wanted everything to be open source. And what that means is that all of the source code for the programs held internally are free and can be modified by anyone. And we also have the hardware open source, so that if you want to modify the hardware in some way, you're free to do that. And we wanted it contest usable. And what we meant by that was, a lot of QRP radios don't have a waterfall. And if you're running low power, it's nice to be able to see who's strong on your rig, because the chances are it's the propagation that with a field day antenna, it's probably propagation that's good between both of you if you see a strong signal. So it's nice to be able to hunt and peck that way. This was the original convolution SDR radio that we built. And it was built by Frank Dreisach over in Germany. And it is just for receiver, hence the SDR designation. It had no transmitter, but it did cover the right frequency. So that was our starting point. So Al built this and got it running in, believe it or not, 3 weeks. A lot of that was because the code was good and functional when we got it. So we really just had to duplicate their circuits. And the code behind this receiver was 18,000 lines of C code, which is a bunch. Okay, so we wanted, it had features that we weren't interested in. We were not interested in RIDI. We were not interested in AM radio. So we stripped some of the stuff out. So we did simplify the code. We also beefed up the processor. We went to a Teensy 4.1. I know you mentioned the Arduino. That's clocked at 20 megahertz. The Teensy's clocked at 600 megahertz. So it has considerably more horsepower. Also, the Arduino has 32K of memory. I think.
Varies.
Yeah, I think it's 32. And this has 8 meg. And it has a half a meg of SRAM. So there's a lot of resources available to us. So we started to breadboard a second SDR that was using the convolution SDR as the guts, taking out stuff, but putting some transmitting code in. So we pared it down, reorganized it, because they had the 18,000 lines in one file. And just to go from top to bottom in the source file took quite a while. So we stripped out a lot of code, and we got it down to 11,000 lines of code. And this then developed into a basic prototype. Now, the thing that's a little weird here, one of the first questions I got when I brought that radio in is, does it support cursor control? No, it doesn't. And the reason is, Al and I did a project with cursor control. And we found that pushing on the screen, all we did was push the radio all around the table because it didn't have enough mass to stay where it was. So we didn't want cursor control. Instead, we went to a switch matrix. And I can put my hand on the top of the radio and reach all 8, there's 18 buttons now. I can reach all 18 buttons with my thumb. And those are controls that you're likely to use while you're using the radio. And so I don't have to worry about poking things. Plus, these are not good pokers. Fat fingers. This is a 5-inch display screen. The code is written so you can use a 5, 7, or 9-inch display. The one on the table there is a 7-inch. And this is a filter control. If you change that encoder, the filter, the audio filter over here, can narrow, go down to 100 hertz, or up to as wide as 6 kilohertz. And it does that in real time. So as you're tuning, you can hear the impact on the signal. And there's normally, this picture was taken before we added it, but now there's a blue bar where that vertical bar is in the spectrum display that shows you the width of that audio spectrum. So as you narrow it, the blue bar gets narrower and so forth. I went by 2. I'm not sure how to back this up. There. Okay, this was the version 12 prototype. It's essentially the same thing, but you can see how you can put your hand up here and you can reach all of the buttons with your thumb and not have to worry about changing anything. And the display is pretty much the same. Then, this was a kit produced by Justin Giorgi out in California. And he sold 100 of these, but these were really expensive. That kit there, the case alone, I think, was $100 a quarter. So it's not really a kit builder's approach to things. Now here's a blow up of the screen, and this is what the audio plot looks like. And right now, these two vertical lines in the middle here, you put the CW signal in between, and it decodes it down here. And it's a pretty sophisticated decoder. Al designed it, so we call it the Al decoder. Al. And it uses the hypergeometric mean, correlation analysis, and a binary search tree to decode the thing. And we can actually see with the decoder, we can see you getting slower as you get tired. Because this decoding speed down here changes. But the decoder can keep up. Maximum latency is about 2 seconds. So the waterfall is what you would expect, but the G90 bandwidth here was 25K max, and this is 192K. So if you're doing a hunt and pounce at a field day or something, you can see a lot of signals at one time without having to change the bandwidth. And then this gives you approximately 15 to 20 seconds of time. So this is really an FFT graph in the frequency and time domains. This over here is the information window. And it tells you what the receiver increment is, what the notch filter is set at. What else we got? We got noise filters off. 1K is 192 kilohertz band spread on this display. We have the speech compressor running at 70%. We've got it set up for straight key, and the decoder is on. S meter. Up here in the top, this is an early display. The top line there was used to present menus that weren't part of that 16 or that 18 button switch matrix. Because if you wanted to change CW speed, you would have to pick CW speed and then enter the new speed. So that requires some information to appear on this top line. So what we have on the switch matrix are the things that you're likely to change during a QSO, and then the submenus are things that you might want to change after a QSO or at some other time. If you have any questions on these, let me know. This is a blow up of those switches. The select button up in the upper left, once you've made a menu selection, you press that and that activates it. And you'll notice we had menu up, menu down. And then there's band switching up and down. The filter, modulate, demod was whether you're doing single side band or code. Mode, no, demod. Oh, demod is also has AM. It will demodulate now, AM. And then mode is what you're transmitting in. And then the noise floor, you can set the lowest point in the spectrum to be the axis or something above the axis if you wish. Notch, we have one notch filter, but 3 different noise filters. And you can toggle between the 3. The main increment, you can choose between 10 and 1 megahertz for the main tuning increments. Decode is for the decoder. The other ones I'll talk about later. Okay, we realized early on that Al is not a double E person. He's a physicist by training, but a very good engineer. And I'm not a professional coder in the sense that I did coding for a living. I taught programming, but I didn't do programming for my livelihood. So we started a website to get people to contribute ideas, things they wanted to see changed. And they're not necessarily very nice to you. And they chewed my butt out good on the menu system. And you'll see that I changed that to meet theirs. And Bill Schmidt is the one that designed the power amplifier and the new board, he switched all of the front panel to I2C devices, so you can hang a whole bunch of independent sensors and switches, whatever you want on it. Whereas my original design was those 18 switches were resistance ladder. And depending on the analog value that came out of that switch matrix determined which option you picked. It worked, and it worked great, but it's not as good as the I2C. And the other guys are other hams who have made major changes in the way the software and the hardware works. This is a block diagram of really what the transceiver is all about. And you can see this yellow background here. So from the ADCs, analog to digital converters, from that point on until the digital to analog conversion is all done in software, which makes it pretty easy to change things. Well, this is how Al's doing the modulation. And the real work is done by the Hilbert transforms. It takes the INQ signals 90 degrees out of phase, runs them through this and separates it out. And we use the Arduino has a 12-bit DAC, and that wasn't good enough. And the Teensy had a 16-bit DAC, that wasn't good enough. So we went to a 24-bit DAC. And then comes out, feeds it to the speaker, or the microphone and speaker. Okay, this is typical. This is the main board. The Teensy goes here. And the other connectors connect to the other boards. Now, the obvious question is, why not put it all on one board? Well, we thought about that, but this is the T41-EP, and the EP stands for Experimenter's Platform. So what we did was we have 5 boards that are the heart of the radio, and each one of those has a maximum size of 100 by 100. So if you don't like our filter board, pull ours out, get a 100 by 100 board, and put yours in, and off you go. So we divided it out into a main board, an RF board, a low pass, a band pass, and a control board. And Bill Schmidt sells all the boards. There's 15 boards now. He sells it for $13. So he's selling them at cost. This is the RF board. And you can't really see it. But these guys, Al and I didn't lay this board out. But they divided into power section, audio section, RF section. It makes it very easy to troubleshoot. And there's all kinds of test points all over the board, which makes it much easier to troubleshoot. You like to wind toroids? I was telling that there's an article in February 25 QST on a new method for winding toroids called the crochet method. And with it, I think it took me about a half a day to wind all of these coils. And that includes measuring, winding, sanding the tips clean and soldering them in place. It covers now, the reason there's so many of these is the coverage now extends from 160 through 6 meters. So we added some more bands, including the mark bands. This is the low pass board, And on the other side, if you look in the box, you'll see there's a whole bunch of relays that do the band switching and switch the necessary coils in and out. All of these are 5-node filters. So each band has 3 coils and then a couple of capacitors in it. We've compared the receiver with the IC 7300, and anything that could hear, we could hear as well. I got something here. I don't know what came up. Okay, this is the 20-watt PA board that Dr. Schmidt designed, and these used to be IRF 510s power transistors, and they're horribly nonlinear. So when you got to 15 and 10 meters, the power just went the toilet. So he switched those out for Mitsubishi's, and now this is linear from 160 through 6 meters, 20 in, 20 out. And he sells that for $19. This is a control board, and it's sort of like the heart, or well, I should call it the brains. It controls which relays are doing what, which board and filter are doing what, and all of the control signals are routed through IDC connectors. This makes it easier to move things around if you need to. This is Dr. Schmidt's website, and if you want to buy any of his boards, just post on there, I'd like to buy the T41 board set. And he'll get back with you and tell you what the price is and shipping. As I recall, I think it's everything including shipping for something like $20. Now this is the more modern display. It's fuzzy because my picture didn't come through very well. But if you remember, the menu used to have menu plus and menu minus. That's gone. And it gave us some freedom to add user-defined things for switches at the bottom. So that changed because our users didn't like what I wrote. So we went to a new menu system. So instead of doing menu up, menu down, all of the main menus are presented here. And you turn the encoder, and that green at the bottom that says voting, that scrolls up and down. When you get what you want, you hit the select button, and then the secondary menu comes up. And in this case, I have it on set offset, and because that requires you to type in a number, then we have you use the secondary menu up on the top. You hit select again, and the waterfall's reinstituted. This overwrites the waterfall. The waterfall is then redisplayed here back where you were. And that's worked out really, really well. This guy is a picture of the audio plant. And we talked about that before. There are a bunch of software features, and people have added a lot. In fact, there's a guy in England who's added a second slice. So he has a 2-slice receiver. He can listen to 2 different bands at the same time. So there's been a lot of things that have been changed, modified, improved upon by the users themselves. Bodie plots, most people aren't used to seeing that as an option on their receiver, or the transceiver, but that's a possibility. I added this bearing option, and the reason is because anytime I operate it from apart, I always put up a sign that says amateur radio in action, public welcome. And people will come over and they'll see what you're doing, you tell them. The first question is, how far away is he and where is he? Okay, so I added this option. And what you do, like if I'm talking to Belgium, I just type in ON and then hit the key and I get that display. And it tells them how far away they are, and it gives you the true azimuth heading for it. Most people think Belgium is straight east. Obviously, it's not. This has all of the DXCC countries in the database, in the software on the unit. Doesn't require internet connection or anything. And their longitude and latitude and mileage or kilometers. You can switch between kilometers and miles. And most of the time that will answer somebody's question, where are they, how far are they? It's a bell and a whistle, a little sizzle, but a lot of people appreciate it. Okay, this is a digital signal processing book that Al and I wrote. And we're in the 4th edition now. And the thing that makes this book a little different is we talk about a digital signal processing concept, like a fast Fourier transform. And then we show you different ways of implementing that in hardware. And then we show you why we selected the one that we did select for use in the SDR. So this is sort of digital signal processing for dummies, in that we've stripped out most of the math and put it in footnotes and appendices and made it much easier to read. You can see the reviews. We have 30 reviews on the latest edition. We have over 50 on the 3rd edition. And the 30 now have a 4.9 review, which is out of 5, pretty good. A little plug. That book sells for $45 on Amazon, and I have 4 copies with me tonight. If anybody's interested, at the author discount, it's $30. So, for what it's worth. Okay, now the tough one. Yes,
This might sound really silly.
I'll give you a silly answer.
Okay. So can one of these be EHF and UHF?
It could be, but it would take major modifications
Would it? Okay.
because all the filter boards would have to be changed. You probably would have to pick different transistors for the power end. So it could be done, but I wouldn't want to do it.
Could you have 2 slices on yours as well? Would that be hard to do?
I could add a second one. It's just, all you have to do is add another RF board. And then figure out some way to switch the display between the 2.
So how much, what are these selling for?
Well, there's a bunch of things going on right now. That was a kit that I bought for $400. The original one that I built, that was the one that was the gray one, the second one that I showed you prototype. I built that for $175. But I had a lot of crap. You know, teensies, chips, all that. Justin Georgi is coming out with a single band version of this that he's gonna sell for under $400. And you'll be able to buy plug-in coils, I think he said for less than $20, that will change your operating frequency. It does away with some switches and some other expensive parts. Then there's another company, I think they're in Australia, and they may be at Dayton. They've come out with it. It's called Wise WISE radio. And they're coming out with a full-featured one, all of the 80 through 10 HF bands, and their target price is gonna be $400. Now, it's not cheap, I understand that, but I would stack this radio up against the 7300, the IC 7300. You could stack it up against the FT 710, and it would come off in second place, but it wouldn't be a distant second. So it's a very nice radio and fun to build. Yes,
I might have missed it. How did you come up with a T41 name? What did that stand for?
the 4.1 TC,
Oh, T41. Oh, that's awesome.
clever, right?
400.
Yeah.
So
Honestly, $400 for a radio that can do all that. And you can compete with $1,000 radio. That's
pretty cool. That's the kit?
Yes,
price?
yes.
So are the boards all ready assembled? You plug them in, or do you gotta actually
You-
populate the board?
He sells the boards bare. Now, he is starting to populate the power amp board. And he's still selling it for 20, so that's a bargain. But I have a feeling that might change. He's having trouble with getting parts now because of the tariffs.
So
Anything?
Then like, can you buy a bag of parts to populate the boards, or you gotta figure that out yourself? Or what?
Well, you know, the way to do this, if I were gonna do it, there's our website is software controlled ham radio. And if you would type that in, you would be in touch with all 3,200 hams. And what I would do is get on there and say, and this has been done before, I wanna build the T41, would anyone else like to go with me on parts? And they get quantity discounts then. And I know in England, they had something like 35 people sign up, and they did pretty well in getting discounts.
So that software controlled radio?
Ham radio.
Ham radio.
Does your front end have any analog preamplification before they see it?
Yes.
It does?
Yeah, and you're free to, you can see my amp is riding on the back panel, one of those little tiny, I think it's a 10-watt amplifier. But if you want something, Al has a much better amp than I do, and his sounds better, but mine's good enough for me, so. And I do mostly CW, he does mostly sideband, so I don't care too much what it sounds like.
That makes more sense. 20 watts on CW is a lot.
Well, you don't need that. And, no. Anything else?
Are there any future stuff? I know it's been kind of all the craze recently, getting into like polar modulation for the finals.
One of the guys has looked at polar modulation because of the work done by Hans with his QMX radio. And two guys are working on it, but I don't know what their status is. They're great guys, they'll no doubt get it done. And Hans has been very supportive. I know Hans quite well, and he's willing to help these guys. So. He's a true fraternal type ham, willing to help. Anything else? Okay, thank you.
Thank you very much.